NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we build an intuition for absolute value and radicals. Our goal is to understand why the square root of a squared variable equals the absolute value of that variable, and how to use this safely. Absolute value measures distance from 0 on the number line. That distance is never negative. We can define it piecewise as absolute value of it equals a when it is greater than or equal to 0 and equals negative a when it is less than 0. Let's visualize distance. Here's a number line. I will place a point at A. The distance from 0 to A is the absolute value of A. When it is positive, that distance equals A. When it is negative, the distance still points to the right, but its length is the opposite of A. Now, the key identity, the square root of a squared is the absolute value of A, not just A. The square root symbol always returns a non-negative result. Example 1, let it equal 3. The point sits at positive 3. The distance from 0 is 3. And we find that the square root of a squared equals 3, which matches the absolute value of A. Example 2, let it equal negative 2. The point moves left to minus 2. The distance to 0 is 2. Notice the square root of a squared is 2, which equals the absolute value of A, not negative 2. A common mistake is to drop the absolute value and write square root of a squared equals A. That is only correct when it is greater than or equal to 0. Compare this with the square root function itself. For x greater than or equal to 0, the square root of x squared equals x. And the square root of x squared equals the absolute value of x, which reduces to x when x is non-negative. This is the key we will reuse. Property 1. Take square root of ab in parentheses squared. Because the inside is a product of squares, you can split the square root into square root of a squared times square root of b squared. Each square root of a square gives an absolute value. That yields absolute value of a b equals absolute value of a times absolute value of b. Quick check with numbers. Let it equal negative 3 and b equal 2. Then square root of a b quantity squared is square root of negative 6 squared, which is 6, while absolute value of a times absolute value of b is 3 times 2, which is also 6. Property 2. For b not equal to 0, take square root of a over b in parentheses squared. Rewrite as square root of a squared over b squared. Then split a quotient inside square roots into a quotient of square roots. Each becomes an absolute value. That gives absolute value of a over b equals absolute value of a over absolute value of b. Numerical check with the same a and b equals negative 3 and b equals 2. Square root of a over b squared equals square root of negative 1.5 squared, which is 1.5, and absolute value of a over absolute value of b equals 3 halves, which is also 1.5. Property 3 connects all powers with even exponents. Look at square root of a to the 2 north. Recognize it as square root of the square of a to the n. That equals absolute value of a to the n. Using the earlier idea, square root of a squared equals absolute value of a. So the result is the absolute value of a raised to the n. This holds for natural n. Numerical check. Let it equal negative 2 and n equal 3. Then square root of a to the 2 north is square root of negative 2 to the 6th equals square root of 64 equals 8. Absolute value of a to the n equals absolute value of negative 8 equals 8. Absolute value of a to the power n equals 2 cubed equals 8. All three agree. We will simplify 3 expressions that look like square roots of perfect squares. First, I will show the problem. Then we will apply one simple rule again. Here is the key idea we will use. The square root of x squared equals the absolute value of x. This guarantees the result is non-negative. Quick challenge. What is the square root of x squared equal to? Step 1. Simplify the square root of 8 squared. We apply our rule and then evaluate the absolute value. Step 2. Simplify the square root of negative 6 squared. Again, the square root of a square equals absolute value. The absolute value of negative 6 is positive 6. Step 3. Simplify the square root of negative 3/5 squared. Use the same rule and take the absolute value to make it positive 3/5. We'll solve 3 expressions step by step, matching the structure shown in the prompt. First, the example, and the 3 targets we will simplify. The key rule we will use at every step is the square root of a square equals the absolute value of the base. That is, the square root of x squared equals the absolute value of x. Step 1. Simplify the square root of open parenthesis 1 minus root 2 close parenthesis squared. Apply the rule to convert the root of a square into an absolute value. Because 1 minus root 2 is negative, the absolute value introduces a negative sign in front of the parentheses. Then distribute the sign to get root 2 minus 1. Step 2. Simplify the square root of open parenthesis 2 minus 9 close parenthesis squared. Convert to an absolute value. Then, because 2 minus 9 is negative, replace the absolute value with the negative of the parentheses. Evaluate to get 9 minus 2, and finally 7. Step 3. Simplify the square root of open parenthesis 1 minus 1/3 close parenthesis squared. Convert to absolute value. Since 1 minus 1/3 is positive, the absolute value returns a positive factor times the parentheses. Subtract to get 2/3. The expression is the absolute value of negative square root of left parenthesis negative 3/4 right parenthesis squared. We'll follow the exact step order. Rule applied. Absolute value of a negative equals the absolute value of the positive. So we remove the outside negative sign inside the absolute bars. Rule applied. The square root of a square equals the absolute value. Therefore, the inner square root simplifies to the absolute value of negative 3/4. Now take the absolute value of a negative rational number. It becomes positive 3/4. Quick challenge. Could you predict each rule before it appeared? Pause and try the next example with me. Second example. Absolute value of 7 minus square root of 50. We will first factor out a negative to reverse the order. Using distributive thinking, 7 minus the square root of 50 equals negative of left parenthesis square root of 50 minus 7 right parenthesis. The absolute value ignores that negative. The quantity square root of 50 is slightly larger than 7, so the inner expression is non-negative. Therefore, the absolute value drops, and the result is square root of 50 minus 7. How would you justify that square root of 50 is bigger than 7? Share your reasoning in your own words. Third example. Absolute value of square root of negative 3 squared minus square root of negative 5 squared. Apply the square root of a square rule to each term. Each becomes an absolute value. Evaluate each absolute value. Absolute of negative 3 is 3, and absolute of negative 5 is 5. Now subtract to get negative 2 inside the absolute value. Finally, the absolute value of negative 2 is 2. In this lesson, we will follow the exact step order shown in the provided solution. We will evaluate 3 expressions using absolute value and square root properties without changing the order of steps. Example A. We start with a nested absolute value expression. First, write the given expression. Next, notice 3 minus root 10 equals the negative of left bracket root 10 minus 3 right bracket. So we can rewrite inside the absolute values accordingly. Now combine the 2 terms inside one absolute value. We simplify to the absolute value of negative 7. Finally, the absolute value of negative 7 equals 7. Key facts used. The absolute value of negative equals the absolute value of A. If it is greater than or equal to 0, then the absolute value of equals A. And we use the property that the absolute value of a difference is the absolute value of the combined expression after simplifying signs. Example B. A square root of a square simplifies to an absolute value. We start with the expression. The square root of parentheses, something squared equals the absolute value of that something. Rewrite the inside as a negative of 4 minus root 3 to match the given solution ordering. Finally, take the absolute value to obtain 4 minus root 3, which is non-negative. Key fact, the square root of a squared expression equals the absolute value of the expression. Then we used absolute value of negative equals absolute value of A to write the non-negative form 4 minus root 3. Example C. Absolute value of a product equals the product of absolute values. Write the given expression. Apply the property absolute of a times B equals absolute a times absolute B. Finally, the absolute value of negative 5 equals 5. and absolute of x squared equals x squared, since squares are non-negative. Key fact, absolute of a times b equals absolute a times absolute b. Since x squared is greater than or equal to 0, its absolute value is just x squared. Summary. We followed the exact step order from the solution. 1. Rewrite inner terms to expose signs. 2. Use absolute value identities to remove absolute bars safely. 3. Combine terms inside a single absolute when helpful. 4. Simplify numerically at the end. These patterns will let you mirror printed solutions with confidence. Simplify the absolute value of -7 divided by x to the fourth. We split the absolute value across the quotient. The absolute of -7 is 7. The absolute of x to the fourth equals x to the fourth because a fourth power is always non-negative. Remember the domain restriction, x cannot be 0. Example 2. Simplify absolute of x over x. The answer depends on the sign of x. If x is positive, absolute of x equals x, and the ratio is 1. If x is negative, absolute of x equals -x, and the ratio is -1. At x equals 0, the expression is undefined. So the piecewise result is 1 for x greater than 0, -1 for x less than 0, undefined at 0. Example 3. Evaluate absolute of -13 quantity raised to the 75th power. First, evaluate the absolute value. We need to evaluate the absolute value of 5 halves minus the square root of 26 over 2. First, combine them over a common denominator. Now compare 5 and square root of 26. Since the square root of 26 is about 5.099, 5 minus square root of 26 is negative. Using the absolute value rule, the absolute value of a negative quantity equals its opposite. So the result is square root of 26 minus 5, all over 2. Problem 2. Evaluate the absolute value of the negative square root of -3, halves squared. Square the inside first. The principal square root is non-negative. The leading minus makes the value -3 halves. Taking absolute value returns +3 halves. Problem 3. Evaluate the absolute value of the square root of -7 squared minus the square root of -5 squared. Use the identity. The square root of a squared equals the absolute value of a. So the two terms become 7 and 5. Then absolute value of 7 minus 5 equals 2. Quick summary. Absolute value returns distance from 0, so it never gives a negative. For problem 1 we compared the two halves, noticed the result inside was negative, and flipped the sign. For problem 2 we honored the principal square root before applying absolute value. For problem 3, we used the identity square root of a squared equals absolute value of a. Our final answers are shown in green. Here is our example. We will evaluate the absolute value of absolute values. The absolute value of 1.4 minus square root of 2, minus absolute value of 1.7 minus square root of 3, and absolute value. Step 1. Evaluate the inner absolute value with 1.4 minus square root of 2. Since the square root of 2 is approximately 1.414, we have 1.4 minus square root of 2 less than 0. Therefore, the absolute value equals the negative of the expression, which simplifies to square root of 2 minus 1.4. Quick challenge. Can you anticipate the result of the second inner absolute value before we compute it? Step 2. Evaluate the absolute value of 1.7 minus square root of 3. Since square root of 3 is approximately 1.732, the quantity is less than 0, so the absolute value is the negative of the expression. That gives square root of 3 minus 1.7. Step 3. Substitute these two non-negative results into the outer expression. Because each inner result is non-negative, the absolute value bars simply return those values. So we rewrite the entire expression as the absolute value of open parenthesis square root of 2 minus 1.4 close parenthesis minus open parenthesis square root of 3 minus 1.7 close parenthesis. Combine like terms to get the absolute value of square root of 2 minus square root of 3 plus 0.3. Pause and reflect. Is the inside value positive or negative? Estimate the roots to decide before we reveal it. Step 4. Estimate. Square root of 2 is approximately 1.414, and square root of 3 is approximately 1.732. So square root of 2 minus square root of 3 plus 0.3 equals about negative 0.018, which is less than 0. Therefore, the absolute value equals the negative of that quantity. The final simplified result is square root of 3 minus square root of 2 minus 0.3. Final answer. Here is our problem. Part A. Simplify the square root of 3 minus 2 times the square root of 2. Part B. Evaluate the expression. 3 times the absolute value of the square root of 3 minus 2 times the absolute value of 1 minus the square root of 3, plus 5 times the absolute value of 0.2 minus the square root of 3 minus the square root of the quantity negative 7 squared. Let's start with part A. The key idea is to look for a perfect square inside the radical. Notice 3 can be written as 2 plus 1. Then the inside becomes the square of the quantity square root of 2 minus 1. The square root of a square is the absolute value. Since square root of 2 is about 1.41, square root of 2 minus 1 is positive. So the simplified result is square root of 2 minus 1. Now for part B, we will decide the sign of each absolute value using a number line. Here is a simple number line from 0 to 2.5. We mark 0.2, 1, the square root of 3, and 2. Since square root of 3 is less than 2, the different square root of 3 minus 2 is negative, so its absolute value equals the opposite. Since 1 is less than square root of 3, 1 minus square root of 3 is negative, so its absolute value equals the opposite. Since 0.2 is less than square root of 3, 0.2 minus square root of 3 is negative, so its absolute value equals the opposite. Finally, the square root of negative 7 squared equals 7 because it is the absolute value of negative 7. Now substitute each absolute value and simplify step by step. Replace each absolute value with its equivalent from our comparisons. Distribute the constants. Combine like terms. The expression simplifies to 0. Here is the problem statement. We will proceed line by line following a clean algorithm, replacing square root of x squared by absolute value of x, then combining over a common denominator, and finally using a case split based on the sign of x. Step 1. For any real x, the square root of x squared equals the absolute value of x. Step 2. Put both terms over the common denominator x times absolute value of x. Step 3. The square of absolute value x equals x squared. So the numerator becomes x squared plus x squared, which is 2x squared. Step 4. Cancel one factor of x to get 2x over absolute value of x. Final step. Because of the absolute value, we split into two cases. If x is positive, absolute value of x equals x, and the result is 2. If x is negative, absolute value of x equals negative x, and the result is negative 2. Let us visualize this on a number value of x equals negative x, and the result is negative 2. Let us visualize this on a number line. Then state the piecewise result. Example 2. Now simplify the fourth root of a squared times b to the fifth times c to the fourth under the conditions that a and c are negative and b is positive. We will split the product, extract perfect fourth powers, and then use absolute values to enforce that even roots are non-negative. Step 1. Break the product into factors and rewrite b to the fifth as b to the fourth times b. Step 2. Extract perfect fourth powers. The fourth root of b to the fourth is b. The fourth root of c to the fourth is absolute value of c. The fourth root of a squared equals the square root of absolute value of a. Step 3. Apply the sign information. Since it is negative, absolute value of a equals negative a. So the square root of absolute value of a is the square root of negative a. Since c is absolute value of a equals negative a. So the square root of absolute value of a is the square root of negative a. Since c is negative, absolute value of c equals negative c. Finally, write the simplified product with a clean order of factors. Summary. In the first, thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.